There's a scene in the HBO series Silicon Valley that remarkably describes a magic number in programming code. Coders are trying to figure out a compression algorithm and they encounter a large integer value. They wonder what it means. It is not commented or assigned to a clever constant name. It's just a magic number. The scene in question is analyzed in the video on YouTube. The link you can find in the description below. But my point is that any number appearing in code all by itself can be a magic number. Any value without reference anywhere else and where another coder must figure out exactly what's going on. That's literally the definition of a magic number. We are having a brief look at magic numbers today. Welcome to myCTalkthroughs. I admit using magic numbers in my code, especially when teaching or in trivial examples. It is far more easier to write something like this here and explain how this for loop repeats 10 times. But the number 10 is still magical. The value has no significance, but in a real world program, it might. The number could be days, testing interval, the size of a buffer, who knows. But no one but me does. And that makes it a magic number. To avoid a magic number from frustrating you or anybody else reading your code in the future, you can employ a constant. I like defined constants like demonstrated in this code here. Now I also need to let this commented out and let's have a look at this. At line 3, a defined constant length is declared. Because of its name, the for loop at line 10 makes sense. Further, because the value is set in a defined constant, changing it at line 3 changes every other reference in the code. What I consider a big advantage of defined constants is that under the hood, this is an agreement that within your code, every defined text will just be exchanged to in the definition trailing term. The preprocessor deals with this, replacing their values, so that length here for example, throughout the source code file in all functions. Defined constant declares in a header file. Header files are available in all source code files that include that header. According to silent agreement, defined constants usually are used in uppercase only. Or within only a single function, you can better use a constant variable instead. And yes, constant variable is a horrible oxymoron. Besides being local to the function and unlike the defined constant, a constant variable also occupies storage in your RAM. Further, constants in the function have a data type and storage classifiers. So this code here, I will copy it in for you here. So this code here could use magic number 7 and I would be sorely tempted to do so. But to avoid a magic number, a constant is declared at line 5. I admit that the statement here, const signed week equals 7, seems a bit too much, and yes it is, especially for a tiny program like this, but in a longer program it can help with documentation and avoid confusion. The const keyword here defines the variable as unchanging. Due to this limitation, the variable must be assigned a value and it is declared as is shown at line 5 in the code. The signed qualifier, this one here, ensures that the value is set as an always positive integer. The week constant is then used on line 6 to set the array size, though this specification isn't necessary with the array containing preset values. Still, the construction is more readable without a magic number. Unfortunately, if I want to compile this, my compiler does not accept the constant variable construction at all. I needed to switch to a C++ compiler to circumvent that problem now, and I want to avoid that, but I can assure you that the code would compile then. But that's a great option to show you another way to feed your compiler with a constant which is assumed as constant, and that is an enum. We just use this here. We just use this instead of our constant or signed statement. It says enum week equals 7, and for me personally that looks some ugly to use an enumeration this way, but if you want to do so to avoid a magic number, in that case I shrug my shoulders and go on. Missing here is now a semicolon, and then the code compiles totally fine. So, if you duck away from creating constants for values, remember that it is by far more work to fully document what a value means in your code. Especially for longer programs, knowing the significance of an immediate value in the code helps debugging potential problems in the future.